Good morning, all of you. Today we are going to talk about linked list. Linked list is one of the easiest topic in data structures and algorithms because it is kind of similar to array, but not fully because array is a static data structure while linked list is a dynamic one. That is, we store the array statically, but linked list we store dynamically. So, uh, okay, just like array, linked list is a, I would say, linear data structure. It is a collection of nodes, and a node contains data and addresses the next node. Linked lists do not use contiguous memory allocation for storage, unlike arrays. There is some similarity between linked list and array, but there is also some differentiation between both of them. Okay. So, just like array, linked list is a linear data structure. Just like array is made up of elements where it stores value. Each element has a certain value according to the data type of the array. But in case of linked list, we store two values, or we can say two variables. Every element of the array or every value of the array is just known as an element, while in case of linked list, it is known as a node. And node is separated into two parts. One part contains the data to that particular node, and the second part has a reference to the next node, that is a pointer to the next node. Okay, it contains the address to the next node. And that is what is written here. A linked list is a linear data structure. It is a collection of nodes, and node contains the data and addresses the next node. It means it contains the pointer to the next node. Now, second point is linked lists do not contain, or basically linked lists do not use contiguous memory allocation for storage, unlike arrays. Like in case of arrays, we saw each element is located one after the other, just one after the other. But this is not the case with the linked list. We do not have to use contiguous memory allocation. We can use, of course, but there is no force on us. Okay, to use the contiguous memory block. That is, individual nodes of the linked list can be stored on different locations, on different memory locations, but they must be connected to each other through the next pointer. Okay, like we saw, one second. Like, let's say this is, we are making an array, okay, of size 5. So, 1, 2, 3, 4, 5. Let's say 6 size array. This is 0th index. Okay. This is first index. This is second index. This is third index. This is fourth index, and this is fifth index. So this is an array where the 1, 2, 3, 4, 5, 6. We have 6 elements, and each element is stored one after the other. Like the index with the element with index 1 is stored after the element with index 0. The element with index 2 is stored after the element with index 1. The element with index 3 is stored after the element with index 2, like, and so on. Every element is stored one after the other. But in case of linked list, this may or may not be the case. Okay, let's say this is the first node of the linked list. Okay, and this contains a this is a, let's say, data part. We'll resemble it by D. This is a data part of the linked list, and this is the next part, which stores the address to the next node or the pointer to the next node. Now, it's not important that the next node of the linked list must be here, somewhere here, like this. It is not important. Okay, so let's say, one second. Just we'll have to rub this. Now, this is the first node of the linked list. Okay, the second node of the linked list can be, let's say, here. Sorry guys, let's say here, this is the second node of the linked list, where this is the data part represented by D. Okay, and this is the next part which stores the address to the next node. And this is the second node. This is the first node of the linked list. Okay, this is the second node of the linked list. So the pointer to the pointer to the second node will be the address of the second node will be stored in this ad address value. Okay, so this will point to this second node. It means that of the first node, the second node will come. The address of this second node will be stored in this variable. Okay. Now, third node, maybe third node is present here. It is not at all important that the nodes are contiguous. Let's say this is represented by D and N represents the reference part. So now this second node, this variable, address variable or reference variable will point to the third node of the linked list. Okay. And let's say after this there is no element, so the this is the third node of the linked list, so the last node of the linked list will point to nothing but null. Okay, so this is the case with linked list. In this way here we can clearly see the difference. Okay, here in this here this is array. One second, this is array represented by A and this is linked list represented by L. In this array every element is contiguous to one another. Okay, matlab every element is stored just one after the other, one next to the other. But in case of linked list, this is not the case. Like first element is stored here. Now second element is not necessarily to be stored just after this first element. It can be stored, but it is not necessary. Okay. So second element is stored here. Now third element is stored here. Fourth element can be stored here. Fifth element can be stored here. But we have to careful with the pointers. Like pointer of the first node must be pointing to the second node. Second node's address pointer must be pointing to the third node. Third node's address or reference pointer may be pointing to the fourth node, and so on. And the last node reference pointer must point to the null. Okay, so this is the linked list basically. Now we are gonna come to code implementation. This is the class of the linked list. It means it basically describes the structure of the linked list. This is the same piece of code which you will have to use in almost every problem in the linked list, or not almost, in every problem in the linked list you are going to use this, because every problem in the linked list will use the node, and node contains data and a reference to the next node, address of the next node. So this code implementation you have to remember, and this you will use in every question or every problem of the linked list. Okay, what it says: class of node where it contains two variable, int data and node star next. Here it is not important to just use int. Data can be of any type. Okay, int, it can be of char, it can be of string, any type. Okay, so we have studied earlier that a node of the linked list contain two parts. One part is the data D, and next part is a pointer to the next node. That is, it stores the address of the next node, and let's say it is represented by N. Now this is the data, and this is the next part. When now this is the constructor push. Every node, this is, let's say, a node, and it contains two variables, data and the pointer to the next node. Okay, so whenever you are going to construct this node, we'll use this constructor function where we'll be provided with the data of the node and the pointer to the next node. That is, where do this node will be pointing to. So the data, which is the variable, first variable in this node will be equal to the data which we are going to pass, and the next will be equal to null. Yeah, okay. By default, it will be equal to null. Let's say we are gonna and it is dynamically allocated, since the memory in the memory of the linked list is dynamically allocated. So we have to use, in case of C++, I'm telling, we have to use new to create a dynamically memory block, allocated memory block. Okay, so what we'll do, we'll just like do this like this, like node star, let's say this is represented by T, and it's equal to new node. You already know the syntax. If you have studied the C++ language, you already know the syntax. Java people can also understand because there is a small syntax differentiation between C plus and Java, C++ and Java. If you know the basic concepts, then you can always switch in between the language. Okay. So new node, we'll pass data. Let's say we'll pass 5. Yeah. And second is, let's say we don't pass anything. Okay. It's not important to pass anything. It will automatically will take that value. So yeah. So after writing this code, what node will be formed? A node uh, named T will be formed where the data will be 5, and the address part will contain null as seen from here. So it will basically point to the null. Okay. It will basically point to the null. So this is the code implementation of the linked list. Now, third, we are gonna talk about the difference between array and linked list. Okay. So some differentiation we can see, like array. In case of array, the size of an array is fixed, and in case of linked list, size of a list is not fixed. I've already told you guys that array is statistically allocated memory, but linked list is dynamically allocated data structure, or its memory is dynamically allocated. Like in case of this, I have told you the memory is allocated using new keyword, and whatever the memory is allocated in new keyword, that is said to be the dynamically allocated memory block. Okay. So in case of array, you all know that array, when we are declaring any array, we specify the size of the array. Like let's say int ar and like say 5. Okay. We do like this. Okay. You already know that whenever we are going to declare any array, we do this by declaring the size. At the compile time, we need size. Okay. So it is a statically allocated memory data structure. But in case of linked list, we do not specify any size of the linked list. Okay. We dynamically allocate the memory block, and yeah. So the size of the linked list is not fixed. The size of the linked list is not fixed. We can make our linked list as long as we want and as short as we want. But size of an array is fixed. We have to specify its size at the compile time. Now, second point, sorry. Okay. Now, second point is that memory is allocated from stack. In case of array, memory is allocated from stack because it is a statically allocated memory block. And in case of linked list, it is allocated from heap. Third point, it is necessary to specify the number of elements during declaration, that is during compile time. In case of arrays, I have told you this, Abhi, just a few seconds ago, that it is necessary to specify the number of elements during declaration. During the compile time, while declaring the array, it is very necessary to specify the number of elements or the size of the array. Otherwise, the compile time error will come. And in case of linked list, it is not necessary to specify the number of elements during declaration. That is, memory is allocated during runtime. In case of array, memory is allocated during compile time, but in case of linked list, memory is allocated during runtime. So there is no need to specify the number of elements during declaration. Okay. In case of array, it occupies less memory than a linked list for the same number of elements. And linked list, it occupies more number of memory. Does anyone know the reason behind this? Actually, what happens in case of array, there is only the data part that we have to store. In every element, there is only the data part that we have to store. Let's say int, the size of the int is 4, so 4 bytes. So we have to store only 4 bytes. But in case of linked list, we have to store 2 variables per node. If you remember, one is the data part and second one is the address to the next node. Okay. So we have to store the data sorry, the both the nodes at the reference to the next node, that is a pointer also, and the data value also. So that becomes double the size, you know. So it requires more, consequently it requires more size or more memory. Okay, linked list is now fifth point is inserting new elements at the front is potentially expensive because existing elements need to be shifted over to the make room. Like if you want to insert elements at the back of the array, it is very easy, it is one operation. Okay, but if you want to insert new elements at the front of the array, it is expensive operation because we have to shift every element to one step at the right, then we can insert a new element at the beginning. Okay, and the shifting of the array, the shifting of the array elements or the swapping of the elements, these elements are, sorry, these operations are said to be expensive in nature. Okay, let's say there are n elements in an array. So if we want to insert an element at the beginning of the array, we have to shift all the n elements to their right one step. Okay, so it's a very expensive operation. While in case of linked list, inserting a new element at any position can be carried out very easily, and it is not as time consuming as that is in case of an array, because in linked list there is no such there is no such that elements are stored consecutively or contiguously. We can store the nodes wherever we want, just we have to maintain the links properly. So if we want to insert a new element, we can just rearrange our links, which I'll tell you in the further videos. We can just rearrange the links and the element will be inserted. This is not only this is not only for inserting an element at the front of the linked list, but at any position we can insert very easily. There's a slight rearrangement of the links or the pointers, just that, and nothing very tough, you know. So yeah. Now sixth point is this point, if you're not getting it, I'll tell you, but after second or in third video I'll tell you. So this is very easy. You will today I'm just giving a brief about linked list, what is the difference between array and linked list, so you can understand that, yeah, that why do we study linked list actually. If there is an already a linear data structure called array, then what is the need of studying linked list? So from today's video you will get a brief idea about it. Okay, so now in sixth point, what says sixth point, deleting an element from an array is not possible, while deleting an element is possible. Okay, let's say if an array is of size 6. Okay, and if you want to delete, we have inserted every element in the array, and let's say we want to delete the element at the index 3, then it is not possible, because if we delete the element at the index 3, then it will not remain an array, you know. It is not possible, we cannot delete actually. If even if we want to delete, we cannot delete an array. Like let's say this is an array. Okay, and let's say it contains 5 elements. Okay, this is the index 0, this is index 1, this is index 2, this is index 3, and this is index 4. So if we, let's say we want to delete this element with index 2, let's say we want to delete this, we can't delete this, because if we delete this, let's say there is no element at this index, then this array is divided into 2 parts. So this will not remain the original array. Whereas we are not specifying that we have to split the array or do something like this, you know, divide the array. We just have to delete an element. So it is not possible to delete an element from the array. While in case of linked list, it is possible, and it is very easy. It is easy as inserting a new element at any position in the linked list. And just trust me, guys, I'm gonna tell you this in the second or third video, and it is very simple, very simple. Okay. Okay, so now we're going to talk about the types of linked list. ठीक है. Types of linked list, basically, or we can say majorly, there are two types of linked list. One is singly linked list like this, and the second one is I'm going to talk about this doubly linked list. Okay. So in case of singly linked list, firstly we will read out the points out loud. Okay. Each node has only one link part. Each link part contains the address of the next node in the list, and link part of the last node contains null value, which signifies the end of the node. Okay. Okay. So in case of singly linked list, basically if we talk about the difference between singly and doubly linked list is from the number of links. Okay. In case of singly linked list, we only have one link. And in case of doubly linked list, as the name suggests, we have two links. Okay. In case of singly linked list, like Hare said, each node has only one link part. Every node of the linked list is having only one link part, and that link part will contain the address of the next node of the linked list. Like the zeroth node of the linked list will the address part or the link part of the zeroth node of the linked list will contains the address of the first node of the linked list. In the same way, the address part or the link part of the first node of the linked list will be containing the address of the second node of the linked list, and so on. Okay. And the link part of the last node, as I have told you guys earlier, the link part of the last node contains null value, which signifies the end of the node. If any node, if the link part of the any node is pointing to the null, it means that the linked list ends there. It is the end of the node, linked list. Okay. So this is the singly linked list, and the first node of the linked list is known as the head. Like this is the head pointer, which stores the address of the first node of the linked list. Okay, like this. So this is called head pointer, and this is a tail pointer. This is called the last node of the linked list. Sorry, not last node. One sec. Sorry, guys. Mm, 1 second. I have to rub this. Okay. There is a head pointer which points to the first node of the linked list. This is the first node of the linked list. Okay. This is the second node, and so on. So this head pointer points to the first node of the linked list. That is, it contains the address of the first node of the linked list. Similarly, there is a tail pointer. Okay. So similarly, there is a tail pointer which contains the address to the last node of the linked list. Okay, it contains the address of the last node of the linked list and points to this. So, okay. So you got now head and tail pointers. Head pointer will store the address of the first node of the linked list, and tail pointer will store the address of the last node of the linked list. Okay. So, okay. Now doubly linked list, each node has two links part. This is the main difference between singly and doubly linked list. Singly linked list will be having only one link part, and that link part will be pointing to the next node of the linked list. But in case of doubly linked list, each node has two links part. Okay. One link part contains the address of the previous node in the list, and another link part contains the address of the next node in the link list. Okay. Like in case of single linked list, there is only one link part, and that is addressed to be as next. But in case of doubly linked list, there are two link part. One link part is known as previous, that points to the previous node of the linked list, and one link part is known as next, that points to the next node of the linked list. Let's say one thing. Let's say this is the node in case of doubly linked list, and it has three variables. Okay. This is the data part, this is the next link, and this is the previous link. This link part points to the next node of the linked list, and this link part points to the previous node of the linked list. Okay. So this is what I am trying to explain you. One link part contains the address of the previous node in the list, and another link part contains the address of the next node in the list. While this previous link part of the first node contains null value, which signifies the end of the node when the linked list is traversed from last, while the next link part of the last node contains null value, which signifies the end of the node. Okay. It means the singly linked list, what happens in case of singly linked list, it can only be traversed in forward direction like this. We'll start from head and we can traverse it in forward direction. But in case of doubly linked list, we can traverse a linked list in both the directions. That is, it is possible to traverse a linked list in forward direction, like represented by F, and also to traverse the linked list in backward direction represented by B. Okay. If you want to traverse the linked list in forward direction, we'll start from head like this, front of the linked list. And if we want to traverse the linked list from backward direction or from the last, we'll start at the end of the linked list. Okay. And we'll just do this node dot previous, this node dot previous. And in case of forward direction, if we want to access the nodes in forward manner, we'll just have to access the next part of the linked list. Okay. So this is the doubly linked list. Now the last slide of today's video, applications of linked list in the real world. Like, why are we gonna study linked list only to solve some data structure problems? No, linked list has its applications in different fields of computer sciences, and also it is very important uh, in context with the applications in the real world. Like, it has a lot of applications in the real world. Okay, let's say first application, in music players we can create our song playlist and can play a song either from starting or ending of the list, and these music players are implemented using a linked list. Like in case of music players like Spotify and extra, like in case of Ghana.com and Spotify, etc. We can create our own playlist. Obviously, we can create, okay, and we can play a strong, like let's say we have created our playlist of 30 songs, okay. So we can start or we can play a song either from starting or ending of the link list or ending of the our music list. Like, and we can start from the first song of the list or from the 30th song of the list also we can start. And these music players are implemented using a linked list. And I am sure that you guys can connect that which type of linked list this music player is using. That is using doubly linked list, because we can access our music player playlist from starting as well as from the ending. Okay, so this playlist is a type of doubly linked list. Okay, that is, it is implemented using doubly linked list. So now, second, we watch the photos on our laptops or PCs and we can simply see the next or previous images easily. This feature is implemented using a linked list. Okay. Like you all know, like you can you watch, definitely watch photos on your PCs and laptops, and you just click on the next button to view the next picture, and on the previous button to view the previous picture if in case it is missed or you want to rewatch it. So this feature is also implemented using linked list, and it is also, this feature is also using doubly linked list. Now, third, you must be reading this article on your web browser. And in web browsers, we open multiple URLs and we can easily switch between those URLs using the previous and next buttons because they are connected using a linked list. Okay. Yeah, you know that. Let's say 1 second. Yeah. So basically, whenever you just enter something in your address bar, or to search something, search bar, you just search and go to that respective page. Now, let's say you are going to some other link, you are going to some other URL like this. So it forms a linked list, okay? Linked list of URLs basically. So if you want to come to a previous one of the previous visited page, you can click on the previous button that is presented on the Chrome to come to the previous page. Okay, so this concept is also using a linked list, and more specifically doubly linked list. So here I've explained you only three real world applications of linked list, but there are, believe me, there are thousands of applications in the real world of linked list. And it is very interesting and at the same time very easy topic which you can easily master. And it is also asked in most of the companies in the interviews. It is asked and it is seriously very important. You can master it in a, you know, what to say, you can master it in a less time, but it will have a very positive impact on your interviews and on your strength. Okay, so this is the basic brief introduction of the linked list. um Tomorrow or day after tomorrow we'll study further topics in the linked list. Like go with the insertion in linked list, how to form a linked list. Okay, insertion in linked list, deletion in linked list, insertion at any position, you know, not only at the beginning and at the end, at any position. Then there comes multiple topics, like you just have to solve some 20 to 22 questions of the linked list, and you can just do any question of the linked list effortlessly. Okay, just have to use your concepts and you can do any questions. So thank you guys. Now I'll take your leave. Hope you understood this brief introduction of the linked list, and hoping to see you again very soon. Thank you. Thank you, guys.